And it continues on with counting principles, but we go a little bit further. We build on the okay, so lesson 10.3, we're going to use permutations and combinations. And this all ties into what we did in the last lesson. So we're going to use our objectives are to solve counting problems involving permutations and the fundamental counting principle, and we're going to use also combinations and solve counting problems that require the use of permutations or combinations. So in other words, we have to choose. We have to figure out how to choose between which one we're going to use, one or the other. Okay, permutations. And I'm going to write this on the board. Basically, permutation is where order matters. Okay, the context of counting problems are ranged, often called permutations, the number of permutations. N things taken R at a time. So N is the total, and R would be the number of ways to arrange it. Like the baseball coach arranging positions, he had 11 players, but 9 positions. So that would be 11 taken 9 at a time. Okay. Deck of cards. You have 52 cards in the deck, but you only have 5 in your hand at any one time. So that would be 52 cards would be N, and 5 would be the R, taken 5 at a time. Okay? Denoted by the letter P for permutation, N is the total, R, number of ways to arrange it. Applying the fundamental counting principle, arrangements of this type. So permutations is where order matters. So permutation. Permutation, this is where order matters. Order matters. Okay. So the equation for that is n factorial over n minus r factorial. So the permutation of n taken r at a time, n factorial over n minus r. Okay. Where notice it emphasizes r is never going to be greater than n. R is either less than or equal to n. These two numbers here can be the same, but r can never be greater than n. Okay? So that you're never going to have more seats than students, for example. Okay? All right. So let's take a look at permutation of 5 taken 3 at a time. Permutation 5 taken 3 at a time. So we would say that n is 5, r is 3. So this would be n factorial over n minus r parentheses factorial. So this would be 5 factorial over 5 minus 3 factorial. So that would be 5 factorial over 5 minus 3 is 2. So basically you're going 5, multiplying out 5, times 4, times 3, times 2 factorial over 2 factorial. And so what happens to the 2 factorials? They cancel, right? So we've got 5 times 4 is what? 20 times 3 is 60. Okay, so our answer here is 60. Well, you can do that on the calculator too. Let's see how we can do that. So what you do here is you put n in first, like this is written. you'd put in 5, and then go to PRB, and then select the first one, NPR, and then 3, and enter, and you get the same thing. Okay, so you can use the calculator for these. All right, questions with that? Okay, so let's look at permutation of 6, taken 6 at a time. And we said before that n could be equal to, r, right? R can be less than or equal to n. Well, in this case, r is equal to n, right? So n is 6 and r is 6. So this would be 6 factorial over 6 minus 6 factorial. Well, that'd be 6 factorial over 6 minus 6 is 0. Remember we said that 0 factorial is what? 1, right? So that's why 0 factorial is 1. Because when you're working with permutations that have n and r the same, then you don't want 0 in the denominator, right? Because that's undefined. So for 0 factorial is 1. So basically it's 6 factorial over 1. Okay? And so if you were to put in your calculator 6 and then PRB and right arrow over to 1 and hit enter, you get 720. Okay, so our answer here is 720. So it's arrangement of 6, taking 6 at a time. So if we had 6 students, 6 seats, there'd be 720 different ways to arrange the seating. Okay? Questions there? Okay. How many ways can you select 2 letters followed by 3? 2 letters followed by 3 digits for ID. Okay, so for here, you've got permutation for letters. You've got a permutation for letters and numbers. So permutation for letters, there's 26 letters, and you have 2 letters for your permutation. Permutation for numbers. How many digits do we have in our numbers? 0 through 9. How many digits is that? Well, if you got 1 through 9 plus 0 is what? 10, right? And how many, and we had 3 digits for our ID cards. So with this, you could do on your calculator 26, and then PRD, permutation, and 2 times, and then 10. Permutation 3. I may have to put that in parentheses. Let's do that again. 26, PRB, 2 times, and then parentheses, 10, PRB 3. That's okay, it's 468, so that was okay either way. So we get 468,000. Okay. Questions there? How many 4-digit numbers can be written using the numbers 1, 3, 5, 7, 9 if repetitions are not allowed? Okay, so this is where we get into permutations, right? So we've got 1, 2, how many totals do we have here? 1, 2, 3, 4, 5. So that would be 5 digits taken 4 at a time. So that's where you get a permutation of 5 taken 4 at a time. So the permutation of 5 taken 4 at a time, that's 5 factorial over 5 minus 4. Factorial. So basically that's just 5 factorial over 1 factorial. Well, 1 factorial is just 1. So basically you're just talking about 5 factorial. So you can go here 5 and then PRB and hit the factorial button. 20. Okay? Questions there? Combinations is where order does not matter. Okay, so combinations. Combinations, order does not matter. Okay, and so we use C for a combination. And so the equation for that is it's the same as permutation, but you have an extra R in there. Okay, so combination, n taken R at a time, n factorial, R factorial, n minus R factorial. Okay, and it doesn't matter if the R factorial is in front or behind. Okay. Again, R has to be less than n. You can't take an arrangement more than what the total is. So a combination of 5 taken 3 at a time and 6. So if we were to look at, so let's look at this. Permutation, 5 taken 3 at a time, and combination, 5 taken 3 at a time. And let's put that in the calculator. So 5 PRB permutation 3, we get 60. So now let's try that with combination. 5 and then PRB. Now we have the right arrow over to combination 3 and we get 10. Okay, so because order doesn't matter, you're going to have fewer ways to arrange it. And so if we did permutation of 6, taking 6 at a time, and combination of the same, permutation of 6, taking 6 at a time is 720. And so if we were to do the same for combination, 6, taking 6 at a time, oops, wrong one. 6, PRB, combination, we get 1. Okay? So that's comparing and contrasting between permutation and combination. Questions there? Okay, find the number of ways different subsets for size 3 in the set Math Rocks. Okay, so here we have the set Math Rocks, right? Math Rocks. Okay, so we want to look at the set Math Rocks. So we want to see if there's any repeats. Only one M, one A, one T, one H, R, O, C, K, S. So no, there are no letters that repeat. Okay, so with this, order does not matter. So we would use a combination and take an R at a time. Well, what's our total number of letters? How many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we want subsets of 3. So therefore, N would be what? Do we need to take the cell phones out in the hall? Okay, if it's that important. It's 9, right? And how many do we have in each subset? 3, right? So it's 9 taken 3 at a time. So if you had to do it the long way, it'd be 9 factorial over 3 factorial, 9 minus 3 factorial. So it'd be 9 factorial over 3 factorial. 9 minus 3 is what? What's 9 minus 3? 6, right? So we're going to write 9 out. 9 times 8 times 7, how far are we going to go? To 6, right? Over 6 factorial, and then we can expand 3 times 2. So what can we cancel here? What's the largest number we can cancel? 6. Yeah, the 6 factorials can cancel, right? They're gone. Well, 3, what number is divisible with 3 divides into? 9. 3 can go into 9, and that's what? How many times? 3. And 2 can go into what? 8, and that's what? 4, right? So really what we have here is 3 times 4 times 4 times 7. Okay? So 3 times 4, that's 12. 7 times 12, 7 times 2 is 14. 7, 8. So that's 84. So you can take Math Rocks and arrange it 84 different ways from the letters Math Rocks. Okay, questions there? Okay. A common form of poker. 5 cards, each dealt with a deck of 52 cards. How many different 5-card hands are possible? So again, we're going to use a combination. And this time we're going to use the calculator. Combination. How many cards are in a deck? How many cards are there in the deck? I know you guys know this. 52, right? 52 cards in the deck, so that's our total. And how many are in a hand? 5, right? 5 cards in the hand for poker. So our combination is 52 cards taken 5 at a time. So if we were to do that on the calculator, right, what do we put in first? Here. What number do we put in first? Yeah, the 52. 52. And then we go to PRB. Now which one are we going to use? The P or the C? The C one, right? It equals. Now what do we do? Put 5, right? And then equals. And we get 2598960. 2598960. 1, 2, 3. 1, 2, 3. So there's 2,598,960 different ways to different hands from a deck of 52 cards with 5-card hand. 2,598,960 different ways to arrange a poker hand. Questions there? Okay. Now, this right here has got some really useful information in it. Permutation, number of ways are selected at n number of times. Are items taken n times. So in other words, are taken n time, it's the same. Repetitions, where repetitions are not allowed. Permutation order matters. Okay? I wouldn't leave just yet because this is gonna help you on the homework. Permutation order matters. You look at arrangements of n items. You have your equation. You look for the words arrangement, schedule, order, also some other key words, repetitions or repeats. Repeats or repetitions are not allowed. So arrangement, schedule, or order. If you see those words in the homework, in the problem, use permutation. If you see the words group, sample, selection, committees, or sets, then you use combinations. So combinations, committees, sets, group, sample, selection. Group, sample, selection. And the other one, schedule, order, or arrangement. Or arrangements. So those are some key words. Okay. So on the homework, you have a youth baseball team where coach has 9 players, where batting order may occur. So for selecting a baseball team where order may occur, which one are you going to use? Permutation or combination? Permutation. Order, right? The word order is there. Okay? If you have a question, how many different 3-digit numbers can be written without any repeating? Without any repeating, that would be order, right? Or order matters. So that would be permutation as well. There are 11 members of a board of directors. if they must form a subcommittee of 3 members, how many different subcommittees? So which one are you going to use for committee problem? Permutation or combination? The combination, exactly. So a student is told to work any 6 out of 10 questions on an exam. The correctness of his answers has no bearing. So in other words, order for the exam problem, order doesn't matter which one's correct and what order. So are you going to use permutation or combination for exam problem if order doesn't matter? It doesn't matter which order the questions are arranged, right or wrong. So which one does not, order does not matter? Combination, right? So the exam problem, you're going to use combination. Okay. Questions there? All righty. So we're going to finish up a little early today. And let me know if you have any questions. Otherwise, have a good day.